So the ray of light let me change the marker. So it falls on a rectangular prism of refractive index. The refractive index of the rectangular prism is 1.5. Then what is the angle of incidence of the ray if the angle between the reflected ray and then the refracted ray? So let's draw a rectangular prism. So light hits on it, but let's first have the normal. Marvelous. Marvelous, are you there? Eliana?
Yes, please.
Okay.
Yes.
Okay. So the light hits on the rectangular prism whose refractive index is this. What you have to understand is that whenever light hits a surface, part of it is reflected, part of it is refracted or absorbed. What you see as refracted depends on the nature of the material. If the material is opaque, you can't see the refracted ray coming out of it. If it is transparent or translucent, transparent you see a greater percentage, translucent a smaller percentage. But whenever light hits a second medium whose density is different from the first one, part of it is reflected and part of it is also refracted. Part of it is refracted, and here the refracted ray will be towards the normal. Okay, now you know angle of incidence equals angle of reflection. So this is R, but we know R is equal to I. So instead of R, let's put I because R is equal to I. Now we are told that the angle between the reflected ray and the refracted ray is 90. So this angle between the two rays, we are told is 90 degrees. Okay, so this must be the diagram. This must be the diagram. We have to find the angle of incidence. We have to find the angle of incidence. But we know that absolute refractive index of a material is given by Snell's law. Sine I over sine R. It is also the same as the refractive index of the first medium times the sine of the angle of incidence in it is equal to the refractive index of the second medium times the sine of the angle of refraction in it, which is this. So either you use this or you use this. Both of it must give you the same results. Please, are we okay? Are we okay?
Yes.
All right. So we have the refractive index, 1.5. The bone of contention now is to determine R. Now, when we look at this angle, you see, once this is 90, it means that this plus this must also sum up to 90. Okay, so once the angle between the rays is 90, then this R plus I must also sum up to be 90 degrees. Therefore, R is equal to 90 minus I. Are we clear here? Are we okay here?
No, please.
You see, Akofala, we have the angle between the two reflected, reflected and then the refracted to be 90. Ideally, R plus 90 plus this I must be equal to 180. Isn't it? Isn't it?
Yes, please.
I'm looking for R. So R therefore will be 180 minus 90 plus I. So 180 minus 90, I have 90 minus I. Another way to do the same thing is that, you see, that the angle between the reflected and then the refracted is 90. So the R plus this I must also sum up to be 90. Makovala, am I correct? So if R plus I is equal to 90, and I'm looking for R, I just would have to make R the subject, 90 minus I, which gives me the same results as when I've gone through this whole one. Are we fine?
Yes, please. Thank you.
All right. So, Eliana, Efua, Mary, are you fine?
Yes.
So, refractive index mu, which is equal to sine I on, now R is 90 minus I. So sine 90 minus I. Please, when I was marking, I got some of you saying that, oh, sine and sine will cancel. Charlie, it doesn't work like that. Oh. This is trigonometry. Some of you were even multiplying sine 90. I even saw sine 90 minus sine I. Charlie, this is not algebra for which you have to multiply like that. This is trigonometry, okay? There is a way of expanding this. Are we okay? But then, if I have, look at this. Mary, are you there? Mary Clark. Yo, if I have this, and this is 90, right angle triangle, and this is I, what will be this angle? Brittany, what will be this angle? If this is 90, this is I, what will be this angle? Brittany Bartels.
The angle will be 180. Wait.
Brittany, you are right, but long method. Give me a quick. You are correct, but
180 minus 90 plus I.
Brittany, you are right, but that is long method. Give me a quick one. Okay, let somebody else come in. What Brittany is saying is right, but I want a quick one. Yes, Eliana. Yes. What will be this angle? A quick one. A quick method. I don't want 180. Your papa is equal to 180. Exactly. Brittany, the answer is 90 minus I. Because, you see, this is 90. It means that this plus this must also sum up to be 90. Okay, so if I have this and I want this, all that I do is to subtract this from 90. That's a quick one. But of course, Brittany is the same as representing this by x plus 90 plus I must be equal to 180. Yeah, Brittany. Oh, Brittany, your line is breaking. Okay, so it's the same as what you were saying.
Mr. Ike, please, I said that at first. I said 90 minus I or 180.
Okay. Then I didn't get that. Sorry. Good. So this is 90 minus I. Now look at something. If we take, assuming this is A, B, C, let's find sine of this and cos of this. When we finish, we find sine of this and cos of this. Marvelous, what will be sine I? Sine I. Let's hurry up. Marvelous, are you there? Oh shit. Okay. Adwa. What will be sine I? Quick one. Adwa, let's hurry up. Time. Okay, so sine I will be A over C. Okay, then cos I. And what will be cos I? If you delay, I'll answer, so hurry up. Cos I. Okay, cos I would be B over C. Okay, so let's then look for the sine and cos of the other angles. The other angle is 90 minus I. So what is sine 90 minus I? Akofala, what will be sine 90 minus I?
Is it a piece B?
Area. So sine 90 minus I will be B on C. What about cos 90 minus I? Ileana. Cos 90 minus I. Ileana.
It would be A on C.
A on C. Please, if you are called to answer, let's manage time, okay? So, look at it. It means that when you compare sine I cos I to this, we can deduce that sine I is equal to cos sine I, which is A over C, is equal to cos of 90 minus I. Because sine I is A over C, cos 90 minus I is also A over C. Then cos I is also equal to sine 90 minus I. So look at it. I have refractive index to be equal to sine I over sine of 90 minus I. I've been able to deduce that sine 90 minus I is equal to cos I. So in place of sine 90 minus, I'm going to put this. Please, are we okay?
Yes, please.
Miss Adia, please can you go over the deduction and the proof of sine 90 minus IB
Let's
equals
finish.
to
I'll come back to it. Let's finish. Okay. So we have the refractive index sine I over cos I. Nana Jemfo, are you there?
Yes, please.
Go. Okay. Please let's go over. I think I can ignore this part from the start up to this end. Can I?
Yes, please.
Okay. So let's pick it from here. So we have the refractive index. Brittany, are you there?
Yes,
Okay,
please.
good. Now let's draw a right angle triangle. On a right angle triangle with interior angle of 90. Okay. Let's have one of the angles. It can be up or down, please. This is I. It means that this would also be 90 minus I. The opposite side is A. The adjacent side to I is B. The hypotenuse is C. Okay, we are taking sine and cos of this and of this. Okay, so sine I from what we have is equal to opposite over hypotenuse. So A over C. Then cos I is equal to B over C. Okay, let's take the sine and cos of the other angle. Sine 90 minus I. This is equal to, this time this side becomes the opposite, B over C, and then cos 90 minus I become A over C. A over C. So from what we've done, we could deduce that sine I equals cos 90 minus I. Okay, God, they are all equal to A over C. And we could also deduce that cos I equals sine 90 minus I. Okay, and please, let's use values, numbers to clarify this. That is why when we have angle 30 and 60, supposing this is 30 degrees, this will be 60 degrees. So long as this is right angle triangle, are we okay? And so without punching, I could easily tell you that sine 30 must be equal to cos 60. Because once I have I to be 30, then the other angle will be what? 90 minus 30, which is 60. So without pointing, I could tell you that sine 30 is equal to cos 30. And sine 30 is equal to cos 60. Okay, and so cos 60 must also be equal to what? Sine of 60. Because it's because of this rule. Please, are we okay? So let's substitute this into our equation. Okay, so because we have the denominator to be sine 90 minus I, quickly I can substitute cos I. So I have sine I over cos I. I have mu to be 1.5. Now, because they have this time the angles are the same, I. Sine over cos is tan. So this is tan of I. So that if I am to determine I will be equal to the tan inverse of 1.5. And that will be equal to, that will be equal to Akofala.
Sorry, Miss
Semo.
Edia, 6.3.
56 points. And that's the value of I. Now, if I don't want to do this, if I don't want to, perhaps I don't know this, there's another way out. And the other way out is expanding the denominator using trig identity. Please, can I clean this end? Can I clean? Please give me a minute. I'm coming, okay? I'm coming. Yes. Hello. Hello.
Hello,
Okay.
Mr. Adrian.
Okay. So the other way out is, let's expand the denominator. We have sine of 90 minus I. Okay. Using the trig identity, whenever you have two angles, compound angles, sine of A, this is minus, so minus B. Okay. And we use this in projectile motion. Don't forget, we apply this in projectile motion. So if you have a compound angle, this is sine of 90 times the cos of the other angle, I, minus cos of 90 times the sine of the other angle, I. Okay. Sine 90 we know is 1. So this is cos I. Cos 90 is 0. So everything is 0. So when you use trigonometry to expand, you also arrive at the same answer, that sine into bracket 90 minus I would be equal to cos of I. So this is the other way out. Please, are we okay? Are we okay? All right. Then, do I clean the board?
No.
Hurry up. If you have any question, if you don't have any question, then we move on. Nana Dubia, are you okay?